Good evening, friends, and welcome to another interview preparation session. So today we'll be dealing with some data science questions, data science algorithms, basically. Okay, so let us take the first question for today. So for today, first question is, what is dimensionality reduction? Friends, so you can put your answers in the chat box if you want. Okay, friends, so let me give you the answer. Yeah, so dimensionality reduction. Yeah, so for this, what we do is we reduce the size of the data set. So how can we reduce the size of the data set? So we can drop unnecessary features. So one thing to remember while dropping unnecessary columns is that overall information of the data set should remain intact. So there should not be, or there should be minimum loss of information while we are doing dimensionality reduction. Okay. So yeah, taking the next one, what is the benefit of dimensionality reduction? Okay, friends, so let me tell you the answer for this also. Okay, so the benefit we get, so we are reducing the size of the data set here. Okay. Yeah, so yeah, let me jot down the points. So we have faster processing of the data, as now the data has been reduced, load time consumption, okay, low noise, as we are deleting all the noisy data here. Then we have better model accuracy. Okay, so let's take the next one. What is a recommender system? Recommender system. Okay, friends, so let me tell you the answer. So recommender system are any system which consumer facing or content driven or any online platforms employ to generate recommendation for user from a library of available content. Okay, so these system generate recommendation based on the user's taste and activities on their platform. So suppose like Netflix, you're watching some action movies. You're always watching action movies, so it will recommend you more in that section only. Yeah. Okay. So now next one. What are the types of recommendation system? Okay, so there are two types of recommendation system. One is collaborative filtering type, collaborative filtering. Another is content based filtering. Okay, so well, let's take the next one. What is collaborative filtering? Then recommendation system. Okay, so here we use similarity to consider. Wait. Yeah. So here we use similarity of users. So if in this technique, if a user is similar to another user, so likes of a user or dislikes of one user. So suppose there are two users, A and B. So suppose A is similar to B. So whatever A likes or dislikes, we recommend according to the likes and dislikes of A to B. So in this filtering, we generate recommendations using data about the likes and dislikes of users similar to each other. Okay. So if user A likes a movie, so we can just recommend that movie to user B, who is similar to user A, and vice versa also. So if user B likes something, we can recommend that to user A. Next, what is content based filtering in recommendation system or recommender system? Okay, so for content-based filtering, what we do is we first see what a user likes or dislikes. Okay, so it is generated by making use of the properties of the content a user is watching or interested in. So if a user is watching movies of action or fantasy genre and giving them good ratings, so we just recommend those kind of movies to that particular user. And yeah, so we have a high probability of the users liking those means recommendations and using those recommendations to watch the movies. So that is content based filtering, in which the content of the movie or the item is taken into consideration while generating recommendation for the users. So here we see similarity. In collaborative, we see similarity. And here in content based, we see the user's personal likes. Users personal likes, you can say. Here the content is being used to recommend. Okay, next, out of these two, out of collaborative and content based, which is considered better and why? Okay, out of these two, content based is considered better. And the reasoning for that is content based users personal likes and dislikes, and collaborative uses similarity of users. So whether it may be a situation where user A likes something and user B does not like the same thing, but they have similarity in other things. So while recommending that thing which A doesn't like and B likes, we cannot say that this is working. But when we are seeing a user's personal likes, so we get to know the users better, and that way we can just provide them better recommendations. So this content based is used on majority of online platforms like Netflix, then Amazon Prime, also Spotify, and many others. Spotify. Okay. Okay, so let's go to the next one. Next question is, what is cross validation? So what is cross validation? Yeah, Sada. Yeah, so we use genre for content based. Okay, so cross validation is a model validation technique which is used to evaluate how the outcomes of a statistical analysis will generalize in independent data set. So after model building, while evaluating, we just keep small data which is kept away from the model. So we just treat it as an independent data set and we test how the model is performing on this independent data set. Okay, so that is known as cross validation. Yeah, so the goal of cross, sorry, Sada. Yeah, correct. So cross validation's main goal is to term how a data set is performing at the training phase. So it limits the problems like overfitting, and it is useful in gaining insights on how the model will perform on an independent data set. Okay. Next is, what is k-fold cross validation? Okay, so in this technique, what we do is we divide the data set into k equal parts. Divide into k equal parts. Okay. Then we loop over the whole data set k times, loop over whole data set k times. Okay, and for each iteration, what we do is we keep one of the part as the test data, and other k minus 1 parts are used for training. So for each iteration, we take a different k, different part of k as the testing and training data. So using this for k times when it is looping, so each of the uh, k parts of the data set are coming in testing and training both. So it gives us a good result accordingly. Yeah, fine, correct. So here iterate over the data, taking one part as test and other and k minus 1 part as train. So this is the process for k-fold cross validation. Okay, let's go to the next one. So next is, what is ROC curve? Yeah, fine. So what we do is we first divided the data set into k equal parts. So for each iteration, we take one part as the test and other parts as the training. And for the next iteration, we take another part as the test and the other k minus 1 parts as train. So like this, every part means every k parts are taken as test and every k minus 1 part is taken as train. So every k equal parts we are having. So every part is coming once as the test data. So like this, we test for cross validation. Yeah, the ratio could be anything. Yeah, basically, test should be smaller in size. Yeah. Okay, so coming back to ROC curve. So it is a plot. Yeah, it is a plot between true positive rate and a false positive rate. Okay. So plot between true and false positive rate. Okay. Yeah. So here we have graph like this. So this is true positive rate. This is false positive rate. And these can be calculated from the confusion matrix. So whichever model has a curve which is greater. So basically we check here area under the graph. So whichever area is greater, the model is better. So we can calculate from this AUC or area under plot or graph. So whichever area we are having greater, the plot means the model is better. Okay, yeah, let's go to the next one. So what is RMSE? Okay, so RMSE stands for root mean squared error. Okay, so this is an evaluation metric used to measure the accuracy in regression problems. So basically it is used for regression. Maybe for one only. So it is used for regression. Okay, so how do we calculate this RMSE? Yeah, so friends, how do we calculate this RMSE? So first we find the error. First we find the error, which is equal to the difference of actual and predicted values. So actual minus predicted. Okay. So after finding the errors, we square them. We square them and then we find out the mean of them. So after finding this, we square them. Then we find the mean. Then we find the root of the whole thing. Okay. So by this, we can get the RMSE value. Okay, let's take the next one. So what is SVM? Yeah, fine, correct. Okay, so SVM stands for support vector machines. Okay, so this is a supervised machine learning algorithm which can be used both for regression and classification. So in this, if we are having n features, suppose, or n columns, we can say. So if we are having n columns in this data set, so what SVM tries to do is it tries to plot the data in n dimensional space. So same as the number of features or columns it has, it tries to plot in that many dimensional space, and that dimensional space, it belongs to the value of the feature. Okay, yeah. So SVM, we call this as, yeah, so this n dimensional space is used to divide the data according to our output, and the plane which divides this data is known as hyperplanes. Okay, so SVM uses hyperplanes to separate out the different classes, and these hyperplanes are based on the kernel functions. So we have something called as kernel functions which we use to divide the data. Okay, so let's take the next one. What are support vectors? Yeah, so what are support vectors? Fine, I think you are talking about SVD. Singular value decomposition. We use that for dimensionality reduction. Okay, so friends, what are support vectors? Okay, so this support vectors are the data points which lie closer to the hyperplane. So suppose we are having, let me draw it. Suppose we are having a hyperplane like this. So support vectors are somewhere around here. Okay, and these points uh, are the closest to the hyperplane, and they influence the position and orientation. Okay, position and orientation of the hyperplane are controlled by them. Okay, so these support vectors, if we remove one of them, if I just remove this vector, support vector, then the orientation and the position of this plane will change. Okay, so this position and orientation of hyperplane is totally dependent on the support vectors of hyperplane. This is okay. Okay, so let's take the next one. What is a kernel function? In SVM. Yeah, hello, Payal. Welcome. Okay, types of support vector. Not types of support vector, we can say. Okay, so let me tell you. Yeah, so it is, we can say, mathematical function It is a mathematical function which takes the data as input and converts it into required form. Okay. So the transformation of this data set is based on something called as kernel trick. That is where the kernel function name is from. And using this kernel functions, so basically what we do is, when we are having a linearly inseparable data, we are having, we use this function, kernel function on this linearly inseparable data to convert it into linearly separable data. Okay, so that is what is kernel function. This is basically what a kernel function does. Okay, so now we have different kinds of kernel functions. Let's see what are different kernel functions. Okay, so let's go through them quickly. So we have linear kernels. Then we have polynomial kernels. Then we have ANOVA. We have something called sigmoid. We have Gaussian. Then we have RBF. Yeah, we have many others. So these are all the important ones. Yeah, so linear kernel can be used when dealing with large sparse data vectors. So when we have large amount of zeros in our data set, we can use this. So suppose we are having a data set which is converted by dummy variables. So we are having large amount of zero values. So we can use linear kernel at that time. So it is often also used for text categorization. Let me write, for used in text categorization. Okay. Next, we are having polynomial. It is popular in image processing. Then we have ANOVA. These are basically used for regression problems. Then we have sigmoid. These can be used in neural networks. Gaussian also we can use It is called as general purpose, so we can use in many places. Then we have RBF, which is also general purpose. It can be used in many places. Okay, so let's take the next question. So how can we select the appropriate value of K in K-means clustering? So how do we select appropriate value of K in K-means clustering? Yeah, good evening, Avinash. Avinash, I don't think it is possible, but you can go through the video again. Fine, I don't know about that kernel filter. Yeah, so the way we choose this K for K-means clustering is we first plot a graph by taking different values of K. So basically this graph is known as elbow method, elbow curve. And wherever we see the sharp change in K value, we take that K as the K value for the our data set. Okay. Avinash, I don't have any idea how to get these copies to you. Okay, let's take today's last question. So why naive Bayes has the word naive in it? So why naive Bayes this has the word naive in it? So naive basically means what can we say? Naive means lack of wisdom, basically we can say, or lack of judgment. So why do we call naive Bayes? Okay, so let me give you this answer. So it is called naive because it makes assumptions that each variable in the data set is independent of the other. Bayes, it is based on Bayes theorem. So it is called as Bayes, but naive, it is called because it makes assumptions that each variable in the data set is independent of the other. But in real world problems, we don't have this kind of data set, So it is known as naive Bayes. Yeah. So friends, with that, we'll be closing today's session. And we can meet again in the next week, Monday. From Monday, we can have this. Yeah, friends. So, yeah, thank you. Thank you, everyone.